Hello everyone, welcome back to Mrs. Evans' biology class. Yesterday we talked about controlled experiments and the criteria that a controlled experiment must meet in order to be considered valid. And we also talked about data tables and graphs and how you can read them to determine what the dependent variable is and the independent variable is. So let's review real quick about data tables as far as dependent variable and independent variable. So remember, the rule of thumb in a data table is that the dependent variable is the rightmost column. And the independent variable, you can usually deduce from that. So for this particular data table, we're going to say that the independent variable is the pH of the pond water. So how do you read a data table? So the first thing you want to do is you want to read the title of the data table. The title usually gives you a lot of information as to what the data contains, or what the data is in the data table. This particular data table is not that great because the title only tells you that it is field data. Field data of what, if I was just going to look at the title. So field data, you know that the person collected the information out in the field as opposed to collecting this information in the laboratory. So from there, then you would look at the columns. All right, you got ponds, and you have pHs, and then you have the number of duckweeds. So again, we know the dependent variable is the number of duckweed plants, and then I would presume that the pH of the pond water would be the independent variable. So from the data table, you can look and see, and you can notice that at a pH of 8, all right, that produced the most number of duckweed plants. So my hypothesis would be from that data table is that duckweed plants prefer a pH of 8. So for this particular data table, as I was looking at it and evaluating it, I can see that there's some flaws with it because remember, in order for an experiment to be considered valid, you can only have one variable. But if you look on this particular data table, you see that there are actually 4 different ponds, and then there are 4 different pHs. So realistically, you can't really determine the independent variable because it could be the ponds that they were looking at. So from there, this could be a springboard basically for another experiment. I could hypothesize that duckweed plants prefer a pH of 8. So if my hypothesis would be if the optimum pH for duckweed is 8, then it would produce the most number of plants. So then from there, I could set up pond water with different pHs and see if, in fact, the pH of 8 produces the most number of duckweed plants. Okay, so now you have a data table. So let's just assume that this data table is the best data table ever. Once you've constructed your data table, you are going to use that data table to make a determination as to what type of graph you want to use. Graphs are basically a picture representation of the data. Sometimes it's easier to spot the trend in the data by graphing it. So that's one of the things that you're going to have to do in this class is graph the data that you collect in some of these labs that we're going to do throughout the semester. Okay, so let's look at your options as far as graphs. So depending upon your data, you're going to choose a graph that would best represent that data. So for the field data, I would choose a bar graph because a bar graph is used to show a comparison. So by using a bar graph, I can clearly show the individual that is viewing the graph that the best pH for duckweed is 8. The other type of graph is a line graph. This is probably the one that you're most familiar with because you've used it in algebra and things like that. So a line graph is used to show a change over time, and it's also used to show a relationship. And no, I'm not talking about dating. I'm talking about the trend that you see. And I've included a graph to the right to help me explain that. So this graph is showing you water depth and temperature. So let's review real quick as far as dependent variable, independent variable. So my independent variable is the depth of the water, and my dependent variable is the temperature. So by looking at this graph, I can see that as the water depth increases, the temperature decreases. So I can see that relationship. The deeper you go, the colder it gets, right? That is a clear relationship between water depth and temperature. So sometimes you want to show that relationship. So again, you would use a line graph to do that. And then the last one is a pie chart or a pie graph that is used to show parts of a whole. If you clearly or easily want to show a relationship as far as makeup as a whole out of 100%, you could use a pie chart or a pie graph. For example, if I wanted to show the makeup of this class, and let's say that we have 60% of it is females and 40% is males, a pie chart would easily show that representation pretty quickly. All right, so let's take a moment and look at an example of each type of graph, and I'll take a moment to talk about some information about graphs in general. So here we have a bar graph that's showing a comparison between the number of hours that a student watches. And again, remember from yesterday, let's just quickly identify the variable. So hours would be my independent variable. I know that because it's on the X. And then dependent variable would be the number of students. And I know that because it's on the Y. Now, the first thing that you want to do is look at the title of the graph. The title is going to give you a lot of information typically if it's written correctly. This title is not that great because it doesn't give you enough information. All it tells you is the hours of television watched. So just by looking at that title, I would ask number of hours watched in a day, in a week, a year, a month, what? And then I would also look and say, are we talking about for kids, adults? What are we talking about? And by looking at on the y-axis, I can see, oh, we're talking about students. Okay, well, what's the age of the students? Are we talking about teenagers, kindergartners? You want to try to be as specific as possible in your graph. So this graph shows that the most hours viewed by the most number of people would be 9 to 11 hours. And then the second most would be 12 to 14 hours. Okay, so again, bar graphs show a comparison between different things. All right, so now we have a line graph. Remember, line graphs are used to show a change over time and also to show a relationship between two things. So the first thing you want to do, again, regardless of the type of graph, is to look at the title. This one says people in a store. Again, not a very great title because it doesn't give us a lot of information, what store, where we're at. Okay, and then after you've looked at the title, then you're going to look at identifying your variables. So again, let's quickly review. My independent variable goes on the X, so I know that time is my independent variable, and the number of people is my dependent variable. So from there, let's look at the graph. What information does it tell you? So let's say our store is Walmart. So Walmart asked somebody to come in and count the number of people in the store at the various hours. So they graph the data. So this data, if you show it to a supervisor, they can see, wait a minute, there's a lot of people in Walmart around 1 o'clock. And you can see that they increase steadily from 11 to 12, and it starts to drop off at around 2. So if I was to make a guess, I would say, hey, these are people coming in during the lunch hour, so I need to make sure that I have more people in the cashier to serve the people that are coming in. And again, you can see the trend. It's increasing around lunchtime, and then right around 2 o'clock it starts to drop back off. Again, I would associate that with being lunch. So again, line graphs used to show a change in time and then also to show a relationship between two things. All right, the last example is the pie chart. So again, the first thing you want to do is use or look at the title. You will see that this one is missing. All right, so please, if you're making graphs in this class, don't forget that because that's a big no-no. So I'm left with, okay, what are we looking at? Clearly by this information, I can say that we're looking at web browsers. So from there, I can say that Firefox and Internet Explorer are the two most popular choices, I guess, among people. So again, pie charts, pie graphs show parts of a whole. All right, so far we've been evaluating other people's graphs. So now I'm going to shift focus. I'm going to talk about setting up graphs correctly for the data that you have collected. One of the things that you're going to have to do in this class, like I said, is take the data that you've collected in experiments and then construct an appropriate graph. So let's go over what I call the graphing checklist. First is you're going to need to make sure that you choose an appropriate title for your graph. It needs to be written appropriately for a science class. So as I was going through and looking at examples of graphs, I was pointing out the flaws in their titles. So the rule of thumb for science is that we write the title as the effect of the independent variable on the dependent variable. Again, make sure you choose an appropriate title for your graph. If you are missing a title, you're going to lose significant points for your graph. The second thing that you need to do is make the best graph choice. Look at your data. What is your data showing? Are you showing a comparison? If so, you want to use a bar graph. Are you showing is there a trend that you see that hey, there's a change over time, then you're going to want to use a line graph. And then once you've determined those two things, then you are going to look at your data and determine an appropriate interval or scale for your graph. And I will tell you that I will give you graph paper, and I expect you to use all of the graph paper. So by determining an appropriate scale, look at your highest data point and then count basically the number of lines on the graph paper that I gave you, divide that by the number of lines, and that will give you a ballpark as to what your scale should be. I will make some exceptions here and there because I don't want you to go like 0.12 for your intervals, but try to use up as much of the graph paper as possible. And the reason why I want you to do that is because another benefit of graphing your data is that you can gather information from your graph. Let's say you were graphing the temperature of the water at certain depths, but you didn't measure the temperature at 15 meters. So by using up all of your graph paper and you look at your graph, you can say, hey, at 15 meters, the temperature of water based on my data should be around this interval. So let's say 12 degrees Celsius. But if you do a very small graph, you're not going to get as close to the true number, if you will. So make sure you use all of the graph paper that is available to you. The next thing that you're going to do is you are going to identify your variables and make sure you put them in the correct location. So again, remember, in a data table, the dependent variable is going to be on the right and the independent variable will be to the left of it usually. So I'm going to identify my variables, and then the next thing is to label my axes. The x-axis is the independent variable and the y-axis is the dependent variable. So if the independent variable for my experiment was the depth of water, then I would label that, and then the dependent variable was temperature, then I would label that. And then you need to make sure that you provide the appropriate units in parentheses. So if depth of water was one of my labels, I need to put in parentheses how I measured that. Did I measure that in meters, centimeters, kilometers? What was it? All right, so don't forget those, because if you forget that, you're going to be losing some points, because it's, like I said, it's crucial that you include as much information on your graphs for the viewer, so that they're not left with questions. And then the last thing is that you are going to obviously graph your data, and then check to make sure that you graphed it correctly. And then after you've graphed it correctly, then you will go in and add a key if it's necessary. So let's say that you did a line graph and you have 4 or 5 different lines and you use different colors to represent different people or different areas or whatever. You would then add a key that says the blue line represents, let's say, a fox, or the red line represents a bunny rabbit or whatever. So sometimes you won't need a key because it's very clear on your graph, but if you need a key, make sure that you have that included. All right, so let's go through how you graph the data that's in your data table on a graph. So the first thing, like I said, is you want to make sure that you come up with an appropriate title. So usually the very first thing that I do is make sure that I identify my variables first to help me with my title. So remember, rule of thumb, dependent variable is the one that is on the most right column. So my dependent variable is my plant growth, and then my independent variable would be the pH of the soil. All right, so now I have my 2 variables, and now I can come up with the title for my graph. Now I cheated and typed it so it was a little bit clearer as to what my title would be. So remember the rule of thumb, the effect of the independent variable on the dependent variable. So the effect of pH of soil on plant, I went ahead and said plant height. All right, so I've determined what my title is going to be. So now I need to add that to my graph. All right, so there it is. The effect of soil pH on plant height. So then from there, again, remember, you are going to choose an appropriate graph, and it looks like I would probably want to use a line graph, so that's what we're going to do. And from there, you are going to label your axes. So I'm going to take a moment, pause the video, and go ahead and label those in real quick so that they're kind of clean and neat, and then I'll resume here in a second. All right, so also when you do a graph, you have to determine a appropriate scale, remember, as well. So if you notice, I already went ahead and did that on the graph itself, and let me tell you, that's a little difficult to do it on this screen. So in order to determine the scale, you look at your highest number. So as you can see in my data table, these two numbers right here, 53.3, those are my highest numbers. So you're going to use that, and you're going to count up the number of lines that you have. So I used these, and I used 18 as my number because that's how many lines that I counted up. So you take 53 divided by 18, and the scale is comes out to be 2.94, so you're going to round up. So as you can see, I went up increments of 3. So this line right here would be 3, 6, 9, 12, 15, 18, etc. So then I determined a scale for my pH. And notice they don't have to be the same interval for your X and your Y, just as long as you are consistent in making sure that, you know, for each line here, I went over by 0.1. I can't all go and say, oh, wait a minute, I'm running out of space, and then go by 10. All right, so make sure it's consistent for the x-axis, and then you can choose a different scale or interval for y, but it has to be consistent for each line on the y, okay? So notice I went ahead and labeled the axes as well. You have pH of soil because that is my independent variable, so that went on the X. And then height is my dependent variable, and that went on the Y. And again, make sure you notice here I have the unit of measure, so centimeters, so it's no doubt as to what the unit of measure is. So first, let's go ahead and plot our first point. So pH of soil is 6, so I'm going to go to 6. Let me go ahead and switch back to a pointer real quick and show you how this works. So my first point is 6.0, and my plant height is 25.4. So I'm going to go to 6.0 first, that's here, and then I want the plant height is 25.4, so I'm going to go up here to 24, and 25.4 is probably right there. All right, so I'm going to put my first dot right about there. So let me go ahead and switch to the pen. All right, so there's my first dot. And then you're going to do the exact same thing for the rest of the data. So let me pause it and go ahead and plot those points so it's a little bit neater. All right, so as you can see, I went ahead and added the plots for the other remaining data points. Now you'll notice that they don't quite line up exactly where they should be, and that's because for whatever reason when you're doing this on an iPad you can't get the dot to be exactly where you want. At least you can't, or at least I can't. So please forgive the misplace of some of these dots, but I showed you basically how you do that. So you would, let's say 7.2, go over to, here's 7.2 would be here. This would be my line, and then I'm going to go up to plant height to 22. So that's 3, 6, 9, 12, 15, 18, 21, or sorry, 18, 21. So my dot should be right around in here. All right. So once you've basically put all your points, then you would go in and connect the lines themselves, and you will do it with a ruler to make it as straight as possible. So forgive my crooked lines because I'm sure they will be. So then you'd go back through and connect your dots from there. Again, you're going to use a ruler, not like I'm doing it there. So then from there you would use it to gain information about your graph. So again, checklist, make sure you have a title on your graph, you've labeled your axes correctly, you've indicated the proper unit of measure, as you see here for height. All of these are things that you could lose points for.